As you very well know by now, CO2 is widely blamed for the greenhouse effect. This happens when energy emitted from the Earth is reflected back in the form of heat due to the increasing amount of CO2 blanketing the atmosphere instead of escaping into space. So CO2 carries the rap for global warming and climate change. One much talked about method proposed to reduce the amount of CO2 we vent into the atmosphere is carbon capture and storage, where CO2 is captured, turned into a solid or liquid for transportation, and then stored deep underground. Besides the high costs involved, an additional challenge facing this method is finding suitable places to store the CO2. This is why at CyclicCO2R we decided not to treat carbon dioxide as a negative byproduct to be hidden in the bowels of the Earth. Rather, we view CO2 as an economic opportunity that can be exploited by converting the stored CO2 into a saleable commodity. Specifically, we are creating a process that removes the dependency on fossil fuel and increases the energy efficiency to create a net CO2 uptake in the production of cyclic carbonates, especially glycerol carbonate. As an inexpensive waste product from biodiesel production, glycerol is the main raw material, along with CO2, ensuring cost-effectiveness and, thereby, a maximum commercial potential. So what are the potential uses of glycerol carbonate? There are many indeed. For direct use of the compound in which no further modification is required, primary alternatives include being used as an electrolyte in batteries, as part of a coating in paints, as a non-polar solvent, as a valuable additive to cosmetics and personal care products, and as a constituent in soaps. The use as intermediate is the most promising, however. From a technical perspective, the bifunctional properties of glycerol carbonate make it interesting for use as a chemical intermediate in the production of polymers and complex chemicals. As a green raw material, it will assist in the reduction of the environmental impact of these polymers and complex chemicals. Our first major milestone has been to create a green technology that generates cyclic carbonates, the building blocks for producing polycarbonates with outstanding properties such as impact resistance and optical transparency, giving them vast and versatile applications. Further to this, we strive to make the impact of CyclicCO2R to go beyond this milestone. We strive to inspire. The challenges we have tackled are the foundations of many CO2 utilization technologies, and overcoming these challenges will make further utilization of CO2 in other chemical production lines easier to be economically and environmentally sound. You will find more details on our website. You can also download our free app, CO2Go, to interactively learn more about CO2 utilization.